up soon. You're more than welcome to come in and ask questions of that. We're gonna have a few exam study sessions, so at least in Gilges, I know I'm gonna be doing a study session next Tuesday, 3:30 to 5 in EBU 14309. Or no, EBU 12512. That's right, I got the bigger room. 2512, so the Booker room, Jacobs Hall. And that'll be announced, at least Gilges class it might be, but if you're in Orlitsky's, you're more than welcome to come. The exam, does anyone have any questions about the exams?
Is it going to be based off the homework or some conceptual stuff?
It's a mix. If you've got managed to get your hands on previous year's exams, it's somewhat similar. There's a problem. So I don't know what Orlitsky's is like. It's probably pretty similar. I haven't looked at theirs yet. I wrote the one for Gilges for the most part, so I know what that one is.
I saw Orlitsky's and he had a bunch of conceptuals and then he had like stuff like the homework. Yeah, and you have to see where like the error is or what would happen.
Yeah, so usually and traditionally we've had one question that's kind of like a syntax question, and slash you got to figure out what's going on in the program, like describe the program. There's some short problems that are some stuff you have to kind of trace through, see and kind of follow along and things of that nature. Short problems like basically this happens, what's A, what's B, what's C, that type of stuff. There's usually a short problem couple of short story problems where you either have to do some kind of, it says like, hey, write a program that outputs this, and then you have to write a program that outputs that from scratch. And then there's a program, there's usually something it's more fill in the blanks, like, oh, here's a program with some parts missing, you guys finish it. So if you can do the homework, you'll do pretty well. I mean, it's kind of hard to say if you can do the homework because a lot of people come into lab and we give them a lot of help. If you can do the homework on your own, I'd say you're doing pretty well. So we're having exam study sessions. There'll be some practice exams, or there will be. So just know that you have to write code in your exams that's like syntax good. So you have to actually write that out properly. You get docked here and there for that type of stuff.
Would it be a good idea to use Orlitsky's like practice material?
For either, it's good. Gilges will have one. I know we almost have it done, so I know Gilges is. I don't know what Orlitsky's is. I should take a look at it. But Gilges is going to be somewhat personalized to Gilges exam, so I tried to make sure that it wasn't too much of a clone or something. So, anyways, use the practice exams, look at old exams, look at the old homeworks, look at the solution files from the homeworks and understand what you did differently than what maybe is a good idea to do. And then come to the study things if you guys are really worried. And of course, I'm sure we'll have some kind of office hours. I'm not going to have this. I don't know. I'm probably not going to have this discussion section next week. We'll see. Discussion times will probably get chopped down a bit because honestly, at this point in the quarter, people just come to discussion sections to get help with homework. So I guess we'll keep you up to date on that. We'll spam you guys via TED, spam you guys emails to kind of go over that. Any other exam questions? Okay. All right. So homework. And this is kind of tempted to just sit down and look at this. Okay. So the homework. So most of you have gotten through homework problem 1. Homework problem 1's not too. It's a little. The whole thing is a little simulation. Simulation of two cannons firing the cannonballs. You get the starting height of the cannons and starting speed of the cannonballs. And you kind of, the first problem is you simulate where it goes every 1/10 of a second, a certain increment. And your program is supposed to output something looks like this from problem 1. That's great. It outputs, basically the bulk of it is it outputs the time and X and Y position of each of the cannonballs based on this graph here. So that's the output of your problem 1. The idea is you take the output of your problem 1 and use it as an input to problem 2. And problem 2 looks at each of these timestamps and timestamp and where the cannonballs are. And it prints out this fun little graph that shows the cannonball, where the cannonballs are at that time period, at that time, and it does it for each of the little each time point that you have. I'm gonna actually plug in before I run out of battery. Okay, so everyone's on board with what problem 2 is actually asking you to do, right? Okay. Now, the first thing to explain, I'm just going to kind of explain things that I've noticed through like lots of Piazza posts and emails and my 5-6 hours of office hours yesterday, what people are getting hung up on. And hopefully, I'm not going to do the entire problem for you. I did quite a bit of it in class discussion section, and I'll try to get you guys in a framework at least to be thinking about the right things. So, the first thing that probably confuses people seems to be this seems to be this A dot out with this arrow thing. So what is this actually doing? So this is actually taking, this runs your program, A dot out, and uses file name dot text as an input into your program. So the text that's in file name dot text actually replaces what you'd be typing on your keyboard. So what they ask you to do is to put this text into a file, perhaps let's use p2 test.1. It's this text, and your program basically reads from that text file as if it was typed in. Now, this isn't the same as if you're inputting from a file straight within C. You'll get to that in a little bit, so don't worry too much if you start reading like, okay, file input, you start reading like file pointers and this and that. That's not what we're trying to get you to do. This literally just pipes the input, well, don't worry about that. This literally takes the text from this file and uses it as if you were typing it in. So if this text was here, this text was in file name.txt, and you have a scanf routine. It scans in from this line, and then if you have another scanf routine, it scans in the next thing, and the next thing, and the next thing, and the next thing. Okay. So that's what that means. This thing here is maybe a little confusing. All this means is the same thing as before, but this little thing pipes the output to more. So it pipes the output of A.out to the more program. So you guys have probably used the more program to display text like in a quick way instead of opening up in Vim or Emacs. This just makes it output the text through the text that this prints out to more. It's not that important, okay? It's just like a slightly prettier way to like output your text while you're running your program. Not that important, okay? Not that important. It just outputs the text from your program through more. Okay. So that clears up a couple of those things. So let's look at this program, what it's supposed to do. So this program is supposed to take, this is input, so as if you were typing this crap out, and take this as input and output a little graph for each one of these time points. So more specifically, let's look at, of course I never have internet here. Let's look at, once I connect. let's look in the public directory. So up a directory from your regular home directory, there are the test files. This is, so for instance, two one. So for instance, if you use this as an input, your output should look like, you guys can access all this stuff too, the public directory, as long as my internet, there we go. So for this input, you should get an output that looks like this, okay? So you have time 0, and then it says cannonball 1 is negative 1015, and cannonball 2 is 1015, all right? Then it goes, then it puts a new line. So some of you people, what's up?
Those are text files, right?
Yes.
Like, if we're doing this from home, can you just open it up in your,
Yeah, so if you navigate to it through WinSCP, and you don't want to, if you navigate it through WinSCP and you open it up, kind of like I did, you can edit it if you'd like.
but just look at it and just do more on the file?
Yes, yes, these are just text files. I'm just trying to show you, so this is your input text file, like I just said, like this is what your program takes as input by using that little arrow sign. So you're scanning, this is your input, and this is what your program is supposed to output to the screen. I just used the output text file just to try to show you, because the homework write-up is, we don't show like all of this, so it's maybe easier just to see. So it shows each time point, it shows where the cannonball is based off these X and Y, X and Y points, and then it shows it for each time. You can see the cannonball getting closer, 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 boom, and they hit each other. Neat. Yeah, some of you guys who were complaining on Piazza, oh man, like what, my diff file just has a bunch of blank lines. Yeah, if you open up the output file of your output in the test file directory and you compare it to this, you notice that there's just a new line missing in your file versus the other file. So the diff was trying to tell you that you needed a new line compared to the actual solution. Now, I know it was like not written up very well in the homework. I'm sorry, it wasn't my doing, but anyways, that's what it was trying to tell you. So you see what it's supposed to do. Interesting, kind of neat, I guess. So let's look back at this. So now we understand what we're supposed to do. We know we're supposed to scan in each of these lines kind of one at a time and then print out something for it and go to the next one. And there's a few ways, the way you should think about doing this program, and any program that's somewhat hard or somewhat long, is you should try to split it up into logical parts and do each section at a time, okay? So the first thing you should think is, okay, I need to scan in this information. And one at a time until I need to print out something for each one. So I need to scan this information, do something, and then scan it the next line and do something, scan it the next line, do something, keep doing the same thing, right? So let's write an outline. Oops. That's not what I meant to do. So let's write an outline that does that. And I'm not going to be able to have enough time to get into so let's write an out. First thing you should do really is write an outline that does just that. Man, this internet scares me. How slow it is. Just hanging on to a connection here. So, okay. So, Another thing I'm gonna say again, which I probably said to you guys if you come to this discussion section somewhat frequently, is we're going to grade you on your comments. You should be writing good code because you should be writing comments as you type your code. You should be using variable names that make sense. You should be using white space where it makes sense. You should be describing lines that are complicated, and you should not be trying to write your code so it's as short as possible. You should be trying to write it so that it's easy to understand. The compiler does a fine job of optimizing your code. You don't need to try to make it as confusing as possible. If you do that, and I come up to you in lab, in office hours, and you try to help me, you say, help me debug my code, and it's just like the most incoherent, unreadable thing, I'm probably gonna get a little angry because you didn't heed my warning and write your code as such. And furthermore, we're gonna grade you on this at some point, so you really should be doing it. And even more so, you should be doing it for your own good, to start to develop a good habit of doing this, because you're going to program later in your life, and you will thank yourself if you actually write comments and write good code. You should notice that you probably spend about 1% of your time typing out code and 99% of the time trying to fix it and debug it. If you spend 5 extra seconds typing out variable names and stuff just so you can understand it a little bit better, it's going to pay itself off no matter what. And it'll look pretty. So, if I wasn't in a discussion section, I wasn't stretched for time, I would actually put that up. And it doesn't take that much time. Okay, so we said the first thing we want to do is we want to figure out how to read this thing in. That's the first thing that we should think about doing. Okay? So if we're completely lost, we want to figure out how to read this stuff in. So we're like, okay, well, I want to keep reading things in until something happens, so it's going to be in some kind of loop. So okay, so some while loop. So we think that's like, okay, I want it to keep reading things in until something happens, and I don't know how long it's going to keep going, so like for now, let's just use an infinite loop. So while true, while 1. So I'm looking at this, I'm like, okay, so I told you this text file, the way it's doing it, is just like you were reading it in from keyboard input. So it's like, okay, we need some kind of scanf routine, and you guys should know that when you have a particular formatting, you can force scanf to read it in as such. So it's like, okay, I know each line starts with time, colon, space, long float, space. Also, use doubles, not floats. It says right in this homework right up to use doubles. Don't ever use floats for the rest of the quarter. Well, here's the thing. There's like 6 digits of precision past a decimal point. That's not very much. And you start dividing things, you start dividing floats, and you lose that precision, and it just gets messier and messier. Just use doubles. Don't use floats. Okay. So we're like, okay, I know exactly the format it's going to be in because I know to expect that, and I know it's exactly the format that my other one's outputting, and I know it's a little bit lenient on spaces, so I can probably just put 1 space, and it's going to be okay. So it's like time, colon, long float, and then space, and then parenthesis, long float, right? So this should be comma, space, long float. So this should make sense. And then, let's see, at the end I was like, okay, I may or may not need to scan in a new line. I'm looking at this, I'm like, I'm not sure if I need to scan in a new line or not. Let's leave it out for now, and then I guess we'll see how it works. And then we'll decide if we need to scan in a new line or not. Now remember, I'm telling you guys, write small amounts of your program and test it, and then add stuff to it, okay? Testing part by part. The worst thing you can do is try to write the entire program and then say, it doesn't work, I don't know why. Because then you gotta look through every single part of your program and you haven't verified a single part of it. And then I'm gonna get angry at you and say like, why do you have like 400 compiler errors? I don't know. Anyways, do part by part. So, okay, we do this, we're like, okay, we're gonna have to store this in some variables. Let's make some variables that have some names that make sense. So we need some doubles. So time, that seems like a good one, because it's gonna be a time point. Canon 1x, that's canon 1's x, canon Canon 1Y. These are not too long. Canon 2. You can even put C2X, C2Y. That'd be fine with me if you just like explain what it is. Just have it convey some information so that when you're trying to keep track of stuff later, it's easier. Okay, so let's input this stuff in. Time, Canon 1X, Canon 1Y, Canon 2X, Canon 2Y. Neat. Alright, so I think I spelled everything right. Alright, so that's cool. So right now, this is going to keep scanning in stuff over and over and over and over and over again forever. Now, we need to break, we have an infinite loop, so we need to break out of it. So let's think about this. So how can we break out of this? So you guys should remember that scanf returns the number of variables that it scans in and stores successfully. So you guys used this in a previous homework where you're trying to keep track of how many things you scanned in. So let's just look if I can actually read it. Scanf. So I'm too lazy to look through your notes, but I'm sure it says something similar. This is a good place to look for a quick reference on things. So scanf, blah, 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 blah. You can see all the different specifiers if you wanted to, and the different sub-specifiers, and you can kind of convey some information from this. So you can be very specific about what you're doing. And then down here says return value. So you guys should know what return values mean by now. On success, the function returns the number of items of the argument list successfully filled. This count can match the expected number of items or be less, even 0 due to matching failure, blah, blah, blah. Okay, great. So that means that scanf will return 1, 2, 3, 4, 5 things if it scans in all 5 things properly. Now, why is this important? We're trying to figure out when to end, and we want to end when it comes to something that isn't time, basically. How's scanf going to work? It's going to go in the counter line, it's going to say, okay, is this time? Yes, good. Is this a long float? Yes, good. It's going to keep going. When it gets to this line, it's going to say, is this time? No, that's not time. I'm not going to scan in anything more because it didn't match what I asked. And it's not going to fill in any of these things. And it's going to return 0. If it got through 3 of them before something was screwed up, it would say it would return 3 to say it successfully filled, scanned, and stored 3 items. So let's store that information. Okay. So let's store that information in scanf return. Okay. I'm going to have to speed up so I can get through some stuff. Scanf return. Okay, that's great. Scanf return is equal to that. So that should be equal to 5 when we are scanning our things properly. Great. So let's break out of our loop if scanf return is not equal to 5. I'm going to put some parentheses because you guys should liberally use parentheses so that you're very sure of your expressions, what it's properly doing. If you're using ands and ors and if statements and things of that nature, use more parentheses than less to say exactly what you're trying to do. So, okay. And while we're at it, just to try to keep track of stuff, let's put in some debugging information to really help ourselves out. So we know we have to print out this time stuff anyways, eventually, right? We kind of saw each time period, the first thing you actually put is time. So let's just have it printed out right now anyways. So percent 0.1LF, because we can see it's one digit precision. And then a new line, because we can see that. And let's print out the time variable. So we can at least like kind of see how many times it's going through this loop when we're doing it. So we can see if it's actually picking it up each time. Alright, so that's the end of our loop. Let's try this. Return 0. In bracket. Auto format. Boom. Yeah, it's a good trick from them. Alright, so this looks pretty good. Let's compile this. We're going to use all the compiler stuff, options that I tell you to use. Because you know, this is how I grade your stuff. I gotta actually tell it. Can it is too not? dumb. Oh, that was really stupid, huh? I just, by default, just told it to quit without saving. That's alright, I already did all this stuff earlier, so. Let's. Nah, I'm just. Hold on for a second while I delete half the stuff. Actually, because I want to make a point to, bear with me 1 second. Not that folder. Alright, we. Sorry about that. Okay, don't worry about all these extra variables and stuff. Everything else is pretty much the same. Okay, so let's see. This is about where we were, and we had a break statement here. It's not equal to 5. Save this, open it back up. Okay, whatever. Don't worry about that. Alright, so we got our scanf return line. We have it formatted how we had it before. Storing all our things, we're printing out time.
That's just checking the program.
Yeah, I'm just checking it, plus, in the end, we have to actually print it out anyways, right? I mean, that's the first thing we have to do. Plus, it'll tell us basically how many times it's scanning and how many times it's running through. Looks like I have one too many parentheses here. Come on. That's what this Vim is nice and tells me these things. Okay, so this should all be good. If scanf is equal to 5, not equal to 5 should break out. So let's run this. I'm going to actually save it this time. Let's run this. Compile. Okay, see I did warnings, all warnings, so it gives me 2 warnings. I have 2 unused variables. That's because I deleted them, deleted a bunch of code. So we'll just ignore that. It's not an error, so it did compile. Now, we need to do, what do we have here? So I put P2 test already into a text file. So I'm gonna plumb that into our code. We run this, it says, okay, time 0 times 0. So that's not exactly what we wanted to happen. So it looks like it ran through twice and then quit. So why did this happen? So, seems like it went through once, it printed out time equals 0. And this is what I put into the file. So print out the first time, and then print out the second time. Well, I'm not sure what's going on, so let's print out some more debugging information. Always good to have more information. So let's also print out scanf return. That's pretty easy to do. Should help us figure out what's going on a little bit better. This is called debugging. This is called what you guys are supposed to be doing, so you can figure out what's going on in your code, so you don't have to wait an hour in line at office hours. Okay, so we saved that. Let's recompile. There's our 2 warnings for those unused variables. Run our program again. Okay, I didn't put a new line in there, but it looks like time 0, scanf returns 5, so that one worked. And then time 0, scanf returns 0. Okay, well that didn't work. Now, I was like, well, I guess it's not actually scanning in things properly. Put a new line here. So that looks a little prettier. So I guess it's not scanning in things properly. It's only scanning in the first one and it's quitting. Maybe I should scan in that new line, like I said. That seems like a good idea, because maybe it's encountering that new line, it scans in, because it scans in all of this stuff, and then it quits, and then it goes to scan to the next line, and it counters the new line instead of time. So that must be what's happening. Because it doesn't even scan in 1 for the next one, it scans in 0. And then because scanf isn't returning 5, it breaks out of the loop. So this is what you gotta do. You gotta figure out, why is your program doing the things it's doing? Let's go back and investigate and try to make intelligent decisions. What I hate seeing in lab is people just changing things and you're like, well, I changed this and it made it work. Don't change stuff in your program just to change stuff in your program. Figure out why things are going wrong and make intelligent decisions when you change your code, okay? Don't just change things for the sake of changing things. First off, you're gonna break more stuff, and then you're not even gonna understand why it works when it does, which is, you might as well have not done it. So, okay, we put a new line in here, let's see how this, and we made our formatting look a little prettier. Let's see how this works. Sorry. Alright, there we go. Time 0, scan return 5, return 5, return 5, return 5, and then we kind of have this lined up weird so that it shows the time, the last time again, because it doesn't store anything for time again. It uses the previous value, because when the scanf returns 0, it didn't overwrite the last time value. Okay, that's cool. That means we're starting to store in our variables properly. If we were really paranoid, we could print out all of our variable names and a printf statement right afterwards to make sure it was scanning them in properly. But seeing as scanf return 5, I'm pretty confident that things are actually scanning in properly. Okay, so I'm pretty happy about this. I think I saw how it's printing out the time even though the last one doesn't need to. So I'm thinking I'm going to move this up here, because I don't want to print out the time if scanf returns 0, because it's going to print out the last time again. So let's move that. Okay.
Are you in Vim right now?
Yep.
How did you just do that?
You exit out of insert mode. You press DD to cut a line, and then P to paste it.
DD and P?
Yeah, DD. You can't be in insert mode though.
Okay.
Another awesome Vim command when you're not in insert mode is GG equals capital G, and that auto-indents all of your lines, which makes it very easy to tell if you have all of your brackets and stuff in the right order, in the right places, and if you have all of your brackets opened and closed.
Small DD equals capital G?
Yep.
And then DD to P, can you copy as well?
I don't remember. I think you can. I don't use Vim enough. I don't code really, other than this class. Okay. So we're pretty happy with this, and we're being good students, so we're putting in comments as we go, aren't we? Scans in the time and scan in positions. If
So you always put them between your commands instead of at the end of them?
yeah, I just think it's easier to read this way. What do you guys think? I like describing what's in the section below. I like doing that. I like it better. I think it looks cleaner than trying to put them at the end of long lines and stuff. You don't people don't have infinitely wide monitors and stuff. Sometimes if I'm talking about variables, if we're describing these things, maybe I'll do it out here for stuff like this. But personally, that's just what I do. I mean, anything to make it easier to read is basically the idea. Okay, so we have this debug information. We don't need this anymore, right? So So let's just comment it out. In fact, check it out. Debug line or scan after return. You know, that's cool, leave it in there. It's not gonna stay in there when it compiles. Actually, when I read your comments, I say, look, if this person's actually like trying to debug their code and doing it the right way, that's awesome. Maybe you need, maybe something crazy to go on in your program, you wanna re-verify stuff's working, you just have to uncomment it. Great. All right, so we have our information. What's the next thing we need to do? Let's see if we can manage to get this done in 10 minutes. So the next thing we need to do is probably print out. You should think like, okay, so I've got it scanning through each time, it's scanning in each line, figuring out the information. Now I need to have for each time point, have it print out the bracket, the whole thing, right? So the first thing you should do, you should say, okay, now the first thing I need to do obviously is print out this thing with just spaces and not worry about placing the cannonballs. Now I'm not even going to get to the point of placing the cannonballs, which is probably the hardest part of this program, but let's try to get through this part at least. So, okay. So we know at this point we have a singular time, or we have a time and cannonball position. Alright, whatever. Forget my bad grammar, I don't really care. Now print out the ASCII table, or whatever you want to call it, for the simulation point. Okay. So from the last homework, you guys should probably think like, okay, I need to print out, of course, X amount of rows, which they specify for you as 21 rows. So print out, I'm not going to go over this stuff because I want to get through this. So we have to print out 21 rows, including, and then additionally the bottom row. Okay, and then we need to print 41 columns and the outer columns. Okay?